Hey everyone, I've got a compressor on the bench today. So this is the ART PRO VLA. This came out in the mid 1990s, I think. It's funny to think that they're already this old, but they are. So I've owned this one for right around a year and a half, 2 years. They go for not very much money on the used market, eBay, things like that. At least they did. I haven't checked prices recently, but generally this is a pretty well liked compressor. So especially for the price point, these when they came out retailed for I think $300. The successor to this, the Pro VLA 2, which is out right now, and they still make it, I think it only retails for $350. So for the price, if you read some reviews on these, they are very well liked. For the little bit of money that they cost, a lot of people use them, and they are a pretty good compressor. So this one I wanted to look at because there's been a couple issues with it I've noticed over the past year or so that I've been using it. So the first one is just levels. I noticed that when I'm putting audio through this, I've got to have the gain on the output pretty much just cranked all the way to maxed out to provide enough output for it to be usable. And even then, I'm not getting a whole lot of loudness out of it like I should be. So that could be a couple things. We'll talk about that and take a look at it. The second thing is too is if you look on this meter here for the gain reduction, the LED bar strip isn't quite lined up with the actual front panel here. So that's always bothered me. I don't know if it came from the factory like that or if somebody's been in here and just didn't put it back together. So I'm not sure, but I got to take a look at that and fix that. So controls on this are pretty basic. For attack and release, you don't actually have variable adjustments on that. You've just got the fast and auto settings, which are really kind of just the fast slow setting there. And then on the back, you have both the 1/4 inch and XLR inputs, and then a hard-coded power cord, which I'm not a big fan of. They fixed that in the Pro VLA 2. I believe there's a jack on there instead of having that hard-coded. They actually fixed a lot of things with this in the Series 2 model. I've actually seen inside. I've been inside one of those. I've never been inside this one though, so I'll be curious to see how it compares and what's in here. So I will get it open and we'll start taking a look. So just 4 screws holding on the top panel, and then it's kind of tight. Here's what it looks like inside. So bring the camera in and take a closer look in here. So here is inside the Pro VLA, and it's not too bad. So there's a few things that I don't like. So as I'm going through this, I may be critical about a few things, but keep in mind that this is made at a price point. And due to that, there will be some corners cut in terms of cost savings and stuff like that. So, with that said, it's still a good compressor. And again, this is one that like people modify the crap out of this too. Like if you just look on the forums and information out there, like everybody in the world has modified this and does things to this and makes it better and stuff like that. I'm not going to dive too much of that in this video just because I'm not going to modify this. I'm just going to basically repair it and get it to a good state for what it is, and I am happy with what it is and whatever character it may have. I'm not looking to make this into sound like a $1,000 plus compressor out there. So just keep that in mind. So starting on the left here, power supply. I'll talk about that in a minute. It's a very simple linear supply. There's not a whole lot going on there. So I'll note too, I've actually got the schematic for this as well. The schematic is out there available for download if you just search for it. So I've looked at the schematic already, so I have a good idea of at least the circuitry in here in terms of what it's doing. On the right side here is all your analog circuitry for everything really. So any compressor is primarily op amps. You have your 2 optoisolators down here. This is an optical compressor. Let's see, there's one over there. Move it over for this channel. So the parts for these, they call them Vactrols, which are, it's kind of the old school whatever name for them, but they're essentially just an optoisolator. So you've got an LED on one side and a CDS cell, basically a photoresistor on the other side, encapsulated in a little box. So I'll talk about those because there's a lot of interesting things you can do in terms of playing with these if you want to by replacing those. And actually just making them yourself and just playing with different things, which is kind of neat. So, and then obviously you've got your 2 tubes here. These are strictly, actually looking at the schematic, they're not used at all in terms of the actual compressor, the compression circuitry. They're just an output buffer following on the outside here. So the output of the circuitry goes through this tube just as an amplifier basically to give you the tube color per se, which is really just distortion for that matter, and then that goes through and then routes back out through the output volume there, then outside to the output jack. So my thought is on these, because people often replace them These may have been replaced, which explains why somebody's been in here before. So I want to take a look at these. That's actually loose. Yeah, I think somebody's been in here because that one's loose. I'm just going to probably take those sockets off anyway, because I got to fix that. But the spec sheet for this says that the tubes in this unit should be 12AX7s, which is just a standard dual triode. A lot of people, well, I'll say that later on they switched it to 12AU7s for these. I don't know why, but that was what the later models have, and that's what they said in there. But if you look in the manual for the original Pro VLA, it was the 12AX7s in here. It should have. So just pull one out and look. Yeah, 12AU7s. That can focus. So I don't know if it actually shipped with 12AU7s or if somebody else put them in there. Actually, that's a 12AT7. They're not even the same. Okay. So with tubes, dual triodes, there's a whole series of them. 12AU7, 12AX7, 12AT7, many more. And the main difference between them, there's a lot of difference between them, but the main difference between them is the gain, the actual amount of gain that tube has. So if you look on the data sheets for all these tubes, there'll be an amplification factor that's listed in the data sheet, and that's your gain. 12AX7s are typically the highest. They'll say they're like 100. And then 12AU7s, 12AT7s will go down. Some will be 60, some will be 40, things like that. So the fact that these aren't 12AX7s, there's a 12AU7 and a 12AT7, means that both of these have lower gain than 12AX7s, which could be the reason why I'm getting lower volume out of this, which is kind of what I suspected, but I'll have to play with that and see. So there's other options too. There's potentiometers in here as well, which is part of the gain stage that you can tweak and try to get some more gain out of there. Maybe somebody's messed with those. I don't know. I'll probably start just by putting 12AX7s in here and see if I get the proper amount of gain out, and then verify each channel too. That's something I haven't done, to see if both channels are actually the same amount of output. They seem pretty close. I never would have realized these were different, but I don't know. Interesting. So anyway, we'll check that. So the power supply, this is just a standard linear supply, nothing fancy about it. I don't actually have the schematic I have doesn't have the power supply on it, but you don't really need it. It's pretty simple in here to see what's going on. There's 3 voltages basically this thing runs off. You have your plus and minus 15 from right here. This is just a 7815 to 7915 positive and negative voltage regulator, and that runs your op amps, basically all your analog circuitry from those two there. And then you can see the bank of diodes here. It looks like there's actually probably over here because there's at least 6. Typically you have 6 diodes in the circuit, both to rectify and to give protection to the voltage coming off the transformer, to run your positive and negative supply. On the output of the secondary of the transformer, it's center tapped. That's why you got 3 wires coming out of here, which is what you need for a center plus and minus regulated supply like this. And then you just got a ton of capacitors as well for that, both for the input and output filtering and just to suppress any oscillations from the regulators itself. So something here I really don't like is these 2 capacitors, especially this one. It's actually touching this heatsink right here, which this is just bad design. You never want to have that happen, because these regulators are going to run hot. I guarantee if I have this plugged in for a few minutes, these are probably hot enough that I can't even touch them. They'll probably burn me. And having a capacitor like this sitting right up against that heatsink, it's just going to get cooked. So these will probably be the first 2 capacitors in this to die, if they're not already, dying already for that matter. So again, just bad design. So if you look at the footprint in here too, I can barely just see it down there. It looks like the footprint for those capacitors is smaller than what these are, so maybe they didn't have the proper part sizes and had bigger ones in here they were supposed to be. Either way, even if they were smaller, it's still really close to those heat sinks. And you got these 2 tucked down in here as well. Those are probably in the output, maybe the input. I don't like them in that location either, because they're just in that heat, and again, just getting cooked all the time. So it's just not good design. With the regulators, typically you want the capacitors pretty close to it, but I mean, you could space it a little bit further just to give them a little bit more protection from those. And there's no vents on this either. It's completely sealed, so any heat in here, both from the tubes and these heat sinks and everything, is just going to stay in here and make this unit run hot, which is not good for the lifetime of these capacitors. The capacitors themselves are ICs. Those are Illinois capacitors, so despite the name, they're not actually made in the US here. They're China. They're manufactured in China, so they're probably one of the better Chinese brands out there, which is a good thing. So I mean, granted, they're not running Panasonics or the Shikans in here, which would be nice to see. And I guarantee you they're not going to be 105C rated either. I'm sure they're just 85C rated. But those will be something you would probably want to replace on here. I'll go through, I'll definitely replace these just because, again, they're probably already damaged from that, and I'll consider replacing some other ones as well. I'll put all nice Panasonics in here. The second part of the power supply circuit is it's going to be a voltage multiplier. So these tubes are running on a higher voltage for the plate. They're not running near what they should run. I think the data sheet showed it was 45 volts. Yeah, plus 45 volts. It's hard to see right there, but it is labeled. So they're running the voltage multiplier in here to get that up to 45 volts, and that uses some of these diodes and additional capacitors as well to get that voltage up. So that's what the rest of these in here are doing. We'll measure that and see if it actually is 45 volts. Some of the modifications people do is to run these modified power supply, get that voltage up to, it's 160 volts, 180, 200 volts, somewhere more where the tubes actually should be running for that plate voltage. Running tubes like this with a low plate is typically called a starved plate design, and it works, but there are some disadvantages to doing that, and typically the character you get out of the tubes isn't going to be as good for various reasons that I won't get into in this video, but that is one modification I see a lot of people do. So something else I don't like here is, for whatever reason, this fuse holder just has the wire on the primary right off of, the hot wire coming right off the power cord, just sitting here without any type of insulation or anything on it, which is weird. It's like they've got connectors here on the other side for it, so why don't they use one there? I don't know, it's just kind of change, and again, cost cutting. If you're working on this while it's on, of course, just be careful that you don't get zapped by that. So that's not good either. So this capacitor is obviously loose, so must be a broken solder joint in the bottom of the board there. I'll have to look at that. They did attempt to put some type of silicone or something down in there to glue these capacitors down. I'll have to test to see if that's conductive. Some of this stuff, as it gets old, gets conductive, and you can't really see it in camera there, but down around these caps here, as it old and gets brittle and dries up, it gets conductive and causes all sorts of issues, and corrosion for that matter at times too. So I'll check that, make sure that's not an issue. But yeah, so that's the power supply. Again, all of the capacitors in there I'd recommend replacing if you wanted to and you had one of these, and especially getting to the age that these are as well. Alright, so I got the board removed, and unfortunately these connectors are soldered directly on both boards. They're not socketed, so I can't remove them, but it's fine. I don't feel like removing the jack board, but I got plenty of room to work on this right now. Looking at this answers some questions though, because right here, these capacitors, 4, have already been replaced once. So that's why they're oversized. They're too big, and whoever did it did a wonderful job of tearing up the traces and pads, so that's going to be fun to fix as well. And that's why this guy's loose over here. It's basically just about ready to break that trace. So there'll be some repair work I've got to do on those. And looking closer, that's why these 4 are ICs, the Illinois capacitors, and all the rest, now they have a closer look at, are YEC capacitors, which again isn't a fantastic brand. They're just kind of a cheap economy brand out there. So somebody already replaced those 4, that's why it's like that. So I'm going to replace them again with proper size caps and put in 105C Panasonics in there, and probably do the rest as well. There's a ton more capacitors in the signal range. I think I counted 40 something on here. If you wanted to replace all of them, it wouldn't definitely not be a bad thing. I don't think I'm going to do it right now. If the tubes don't fix my audio issue in terms of gain, I'll look at those next, because that would probably be the most likely thing, but I'll hold off at the moment until I actually verify that. And that also explains why this didn't fit as well, because somebody shoved it in there and just didn't bother to do it right. So this whole thing's been pretty much a hack job by whoever worked on it. So all the op amps. The op amps are everybody's, that likes to modify this. It's their favorite thing to play with in terms of swapping out the op amps to all different varieties and stuff in there. This is primarily made of NE5532s and TL074s, which are pretty standard op amps that many manufacturers out there make. So I'm not going to get into that. I'm not going to modify this, but that is something that a lot of people do, is they'll socket all those for both channels and just have fun putting higher quality op amps in there. So I mean, not every op amp is perfectly replaceable. You got to look at the data sheets, and there's different criteria for those op amps in that data sheet that the rest of circuitry may or may not like. So I don't know. It's just something you need to watch out for if you're doing it. But it seems like a lot of people don't. They'll just throw whatever in there and just make it work. So the optoisolators, which are just one channel, there's one of them right here, or the Vactrols as they're called. So these are what really give this compressor its character, because you're actually coupling the audio through a response curve from this device, which all it really is an LED and a CDS cell or a photocell. What it's doing is basically audio comes through and it lights up the LED, and then it triggers the photocell to give variable resistance, and that's what actually, the circuitry following that is what actually clamps and does your clamping to actually limit the audio going through and compress. So these are interesting because there's a lot of things you can do in playing with this if you wish to. Like I said, this is basically just an LED and a photocell inside. So inside that little black box, you've got a LED with a photocell like this, and it's just encapsulated, so there's no external light that goes into it. Now, you can have a lot of fun playing with these if you want. You can use different colored LEDs, because the color of the LED, both in terms of its actual response from current going into it, and how fast it lights up and how bright it gets, varies from different LED colors. If you look at LED data sheets, you can see that. And then the photocells as well respond differently to different color LEDs. So if you wanted to just play with different response curves and stuff like that, that is something fun that you can do there. And then for the input too, you don't have to use an LED. A lot of the older devices, they didn't use these, back a long time ago, because LEDs weren't really available at that time or even exist. So they used other technology. They would use incandescent bulbs. The famous LA2A used an EL panel as actually its light source. There's a lot of different things you can do in there to give this, a different response and just a different character in terms of the way that it compresses, which is kind of neat and kind of fun to play with. So I've got the capacitors back all reinstalled, at least the 4 I was talking about here. And you can see now they've been replaced. You actually do have adequate space between the heat sinks and this first capacitor here, which is how it was actually designed. And that's the frustrating thing. As I was first open and going through this, almost everything I said that was wrong had nothing to do with the actual art design itself. It was primarily just whoever was in here and was hacking around with it, replacing components. So you can actually see the physical size difference between the capacitors that were in there versus the Panasonics, much smaller. And when you're buying capacitors from DigiKey, Mouse, or wherever, especially these larger values, you have to pay attention to the package size, because they come in different actual physical dimensions. Some will be shorter and fatter, some will be taller, skinnier, like this one. So you have to be careful when you're ordering to make sure you actually get the right package size for the device you're actually replacing here. So while I was in here, I tested a couple other capacitors, just 2 of them, and they actually tested fine. I got in here, I checked voltages both with my meter and a scope, and everything is within spec, and there's no actual noise coming through. Everything looks really clean right now. So for the moment, I'm just going to leave the rest of these capacitors for testing. I'm not going to go ahead and replace them at this time. I want to focus more on actually getting those tubes in here before I do anything else. And just a side note too, if you have a Pro VLA 2, you'll notice that your power supply is completely different over here. They actually made a lot of improvements. The transformer is actually a Toyota transformer in here now, and it's just a little bit better design. So tubes. Everyone who modifies this, it's really the first thing they talk about, the first thing they look to do. So looking back at the schematic, they actually note that, at least on this revision, it's the 12 AT7s that they have in here. But if you look at the original manual for this, which I have, it specifies 12 AX7s actually in the instructions for tube replacement. So this is revision E. I don't know what revision this is. I looked all over the board, I couldn't find a revision number. I'm guessing it's kind of early just based on some date codes I saw in here of mid-90s. I think I saw 96 or something. So I don't know. I'm going to go with 12 AX7s, I think, to test this, because that was my original theory of why the gain may be low. I mean, these tubes might just be bad that were in there too. I have a tube tester. It only does emissions testing though, so it's not really useful for checking gain so much. So I'm going to go with 12 AX7s. Normally when I am playing with these things and trying out different tubes and stuff, I've got a whole series of different dual triodes, so 5963s, 5965s, 6829s, 6211s. These are all dual triodes. These are all relatively low gain though, in terms of their actual amplification factors. So I'm probably not going to use that in here, but I like all these because they're generally more of an obscure tube that's not used as often as like your standard, 12 numbered tubes that you see out there for all your audio gear. And they typically work in most circuits, but they, like I said, the amplification factor on those is usually in the 20 to 40 range for all of those, so they are pretty low. So for this, I'm just going to use some of these Mullard new, recently made 12AX7s that I've had sitting around for a while. Tubes are getting really expensive too, so that kind of sucks. So I've got it powered back up with those 2 tubes replaced with the 12AX7s, and just testing here on the bench. I've got my drum emulator just set up here just so I can get a sound source. So this is the actual output, and you compare that to the input. I've got all compression essentially disabled right now. I'm just looking for audio gain through it, and those levels are about the same, which is kind of nice. I was not getting that before. The output based on the input was always significantly lower. I actually had to crank the volume up all the way, basically maxed at plus 10 to get anything out. And you can see now I can totally just overdrive, you know, the output from the gain that's coming in there, which is good. So it is working, which is nice, and I think that resolved it. So again, the tubes just may have been bad. Again, I don't have a good enough tester to actually verify that. I did go ahead and throw them on my tester, and you know, the emissions test that yeah, I did just shows them as fine, but something's not right with the gain there. I will also note that I did put some 5963s in here, which have a much lower gain factor than the 12AX7s, and the output, while it was slightly lower, it wasn't as low as I thought it would be. So the gain factor may not have as much effect on this as I initially thought. Be interesting to play with that some more, but again, the 12AX7s were pretty much spot on between input and output with everything currently set on there. I didn't adjust those pots or anything inside here, so I'm just going to run with those. So now I'm going to put it back in my rack and try it out for a bit and just see how I like it. Again, I haven't used this too much over the past couple of years just because of that gain issue, and it's just been on my list to take a look at it and see what's there. So, and then from there, I'll decide if I want to go ahead and modify anything with it or not. So we'll see. Again, you know, there's thousands of people out there that modify these things, and there's millions of articles and different things you can do and stuff like that. So if you're into that thing and you want to play with it, this is a good, inexpensive platform just to have fun with. So, yeah, this video, I don't know if it was that beneficial in terms of anything, but it was fun anyway going through this and seeing what was inside it. So thank you for watching.